Time flies when you're having fun. Page 1 is going to be sine and cosecant. Okay? Put a little note at the top. The second page is going to be cosine and who? Secant. Why in the world am I putting those together? Because they're reciprocals of each other. So then I have tangent and cotangent, correct? Now, I want you to look at your y-axis. It's kind of heavy on the x side, isn't it? On the positive side. Not a whole lot going on the negative x side of a coordinate plane. Notice that it starts at 0, and then you've got 1, 2, 3, 4. And then it goes, the x-axis looks like this. You've got pi, you've got pi over 2, 3 pi over 2, is this right, Casey? And then 2 pi. And if you notice there, you've got these other, kind of have a big increment and then 2 right around it. What in the world does that stand for? Shut your face. Pi over 6, pi over 4, pi over 3, right? And then pi over 2, and then the same thing. What's it going to be? Pi over 2, what's the next one? 2 pi over 3, 3 pi over 4, 5 pi over 6, 6 pi over 6. You better write this down, because if you don't do this one time, you're going to have to go back and watch this video, and then everybody's going to make fun of you because you're going to be one of a million viewers on HP's YouTube channel. Pi. 5, 6, 6, 6, 7, 6. Isn't that right? 8, 6, which is 4/3. That's not right. That's not right. It is? Doesn't feel right. Sugar. 2 pi over 3, 3 pi over 4, 5 pi over 6, pi. 7 pi over 6, 5 pi over 4. What's right? 4 pi over 3. 3 pi over 2. 5 pi over 3. 7 pi over 4. And 11 pi over 6. Here, 7 pi over 6. That looks like crap. Okay? Y'all, where are all those values coming from? They are the unit circle values. Folks, this is what I want you to imagine. You're getting ready to create by graphing points, x points and y points of each of these 6 functions, okay? Now, you have this capability on your graphing calculator. It ain't going to help you any on a paper graph, but it will at least show you, hey, do I have the right shape, okay? Remember, when you put this in your calculator, you need to zoom 7, I think it is, zoom Trig. That way it's going to give you the shape that you need, but only focus on the positive x values, okay? When you look at this and you verify with your calculator. Folks, if we were graphing sine of x first, I need you to put your finger on the column that is the sine theta column, okay? And if I'm graphing pi over 6 as my x value, then my y value has to be what number? 0.5, right? So at pi over 6, I'm going to graph what number? I'm going to go over right pi over 6, and I'm going to go up how much? 0.5. And you want this to be as accurate as it can be on paper. Go down your column to pi over 4. What is the sine value of pi over 4? 0.7. So I'm going to go up just a little bit. Right? We have to draw a series of dots, and then we're going to connect them with this nice, beautiful curve. We're going to go down your column to pi over 3. And then I want you to go over to the sine value. What did you get? 0.9. You did say 0.9, right?
Yes.
Okay. Pi over 2. Pi over 2's sine value is 1. Okay, so we're going to graph overwrite pi over 2 up 1. Now look at the other values. What does 2 pi over 3 have to be? 0.9. So it better be pretty symmetrical, shouldn't it? It better line up perfectly with this one that I just did over here on the left. This is very tedious. 3 pi over 4 better be 0.7. And 5 pi over 6 better be 0.5, shouldn't it? Do you see that shape that's forming? What happens at pi? It's 0, isn't it? Sine value is 0. Uh-oh. What's getting ready to happen?
We have to erase our numbers because we can't put our dots right there.
No, we can. We can put our dots right there. It's okay.
I'm gonna go there.
Look what's going to happen when we go to 7 pi over 6. What's the sine value? Negative 0.5, so I'm going to drop below. And just go about right here. Oh, you mean right there. I got you now. I bet 5.4 is going to be negative 0.7, isn't it? Is it?
Can I delete? Can I? I mean,
You can do it. Yes, I know what you mean.
wait.
Y'all are wanting to get rid of these, right?
Right.
And you want to put them up here at the top?
Yeah.
5 pi over 4. What was the next one? 4 pi over 3?
Is this where the relative unit and maximum come into play?
Yes, sir. Smarty McFarty. What's... Y'all keep going, you're fine. This might be the only time that you actually write out the x values. Does that bother you? Okay. Well, I don't want to bother you. Pepper, salt, pepper. What was it? Negative 0.5? Was negative 0.5, wasn't it? And then negative 0.7 and negative 0.9. And then at 3 pi over 2, what happened? It was negative 1, wasn't it? What happens at 2 pi? It's 0. What happened at 0? You know, I didn't even ask you about 0. What is the sine value for 0 radians? 0. Check this out. Does everybody have your dots in place? Do you have your? Do you have? Not has. So look what it's going to form. Okay, this, look at me, look at me, look at me. I need to see your eyes. Your eyes. Do not make this a pointy, jagged curve. That is not correct. It is a smooth and beautiful curve. Smooth and beautiful. Smooth and beautiful. See how smooth and beautiful? Shut up. What's yours look like? It better. Talk smack. It better be smooth and beautiful.
So you can just match up your Y values with the denominators. So basically, of all the numbers on the x-axis set up, 1, 0.
Oh, right. Right. Yeah, because they're quadrantal angles. Okay? Now, that's for the sine function. Guess what you just did? You just graphed the sine function. Notice some things about it. Where does it start? 0. Where does it end? 2 pi. It starts at 0 radians. It ends at 2 pi radians. What is this, y'all? What is that really? But not. What is that curve? If I were to take a piece of string and we were to place that string around your unit circle, just so, where there was no gaps, no bumps, and it fit perfectly. And then we were to cut that string and we were to take it out long and place it on this graph, what is this really? Circumference of the what? Of the unit circle. No, it's not the radius. It's not the radius. It is actually the distance around the unit circle, isn't it? Which is circumference. This is the unit circle on an XY plane. This is the sine curve, and you're going to have to see this and know, boom, it starts and ends on the x-axis, that's the sine curve. It goes up, then it goes down, and it goes back to 2 pi. This is what you're going to do for the rest. This is just Monday, isn't it? Is this just Monday?
Yeah.
Holy crap. This is a 5-day week. What the world? Yeah. How many of y'all will I not have? Thursday, Friday?
So you can't learn anything new, like you can't do that to us.
Well, here's what's going to happen, okay? So what's for the video? What's for the video? What is for homework tonight? No lies. You got to do all 6 trig functions. And I'm telling you, if I don't get something to cover up those columns, it is a hot mess for me, okay? I want you to finish all 6 trig functions. This is what I expect. This is not an option. I expect them all to be finished tomorrow, okay? If you have issues, then you need to email me, or you need to say, what? Or you need to get your tail in here early. Second thing,
But I thought it was undefined. I don't even know.
what happens if it's undefined? Look at cosecant. Let's look at cosecant. Because that's the next one you're going to graph, right?
Right.
Okay. Okay. At pi over 6, what's the value? It's negative.
It's 2.
It's negative 2. Positive 2. I mean positive 2. What is it at pi over 4? 1 point something. 1.4.
Yes.
So something like that. What's pi over 3? 1.2. So it's going to get closer to 1. So this is pi over 4, it's pi over 6, that's pi over 2. What is it at pi over 2? 1. And then, won't the next ones just kind of be symmetrical if you look at them? And then what happens at pi? It's undefined. How in the crap do I represent that? What? Say it again. I just put an asymptote there, y'all, and I can't draw the curve. It's not going to cross that pi over, or just plain old pi. So you need to draw a vertical asymptote there. And it needs to go all the way to the bottom of your graph. Now, what in the world am I going to do with my curve, though?
You draw the arrow going up.
You draw the arrow going up, and it better have an arrow on both ends. It's going to go up.
There's an asymptote right there too.
There is an asymptote right there. But it's going to look something like that. And then we jump over pi, and you start the process all over again. It was negative 2, wasn't it? What was that next value? It was negative 1.4, negative 1.2, and then negative 1. That was at 3 pi over 2. And then what happened at 2 pi again? Another asymptote. So what's that curve going to look like? It's It's just going to look like an upside down, kind of going to look like a parabola. Does that help on the asymptotes? Now, let me just show you what these are going to look like. These are going to look funky. Very, very funky. Cotangent will look kind of normal. It's all the reciprocals look kind of funny. Okay? Tangent is all jacked up. I'll just tell you it's all jacked up. Okay? Let me show you how to verify this. What function is that right there? That's cosecant. Okay? Let me show you how to check it in your calculator. What are we checking? Let's check sine of x. And it ain't even showing me anything. Zoom. Zoom Trig. Zoom 7. You see that? Do I need to be concerned about anything over here on the left? No. I only need to be concerned about this stuff on the right. Does it resemble the graph that you have on your paper? Yes. You can make, folks, hold on a second, I'm not trying to go in.
What?
Pardon?
Can you put it in the
Put it in the calculator, Zoom 7. Zoom Trig.
If it wasn't calculator.
If you want to verify these in the calculator.
Can I see where you put like what you put on the back?
I got it. I just put sine of x.
Okay.
And then I graphed it. And then I hit Zoom. See the 7? Zoom 7. Savannah, what were you going to ask?
What if like you know how you can store a number for x? What if you have something stored for x?
Then don't unstore it.
I don't know how.
Clear your memory. Clear your memory and reset everything. Folks, do you know what you're responsible for tomorrow? It is on like Donkey Kong tomorrow. Ooh, unit circle quiz 1 through 3 tomorrow. First thing. For quiz Q1 through Q3 tomorrow, right? Q1 through Q3 is tomorrow on Tuesday. And then we're going to graph a lot of stuff for sine and cosine tomorrow. We're going to graph a lot of stuff on Wednesday. And then on Wednesday, what's going to happen on Wednesday? Nothing. We're going to learn on Wednesday. Okay? Thursday. What's going to happen on Thursday? Mandy's, you will not be here, correct? Because y'all leave early Thursday morning. Hold it. Q1 through Q4 is on Thursday. And then Friday you will have a quiz. We won't be learning anything new but this much. I record it every day, no excuses. Love you. Have a good day. Motivate.